Okay, guys, we're going to be doing some farm math here. I hope you enjoy the meme that I provided for you all. Just so you know, I don't know if the way I solve these are the easiest ways of doing them. I solved them off of prior math knowledge I have, and I think I did them all correctly. I hope so. So let's just get started. I do jump around between them because I noticed some of them are related, so I put them in like related order here. So let's get started here. Trying to get started. Okay, here we go. Okay, so how many milligrams of this stuff is needed to prepare 3 liters of 1 in 30,000 solution? Okay, so let me get my pen here. Okay, guys. So how many milligrams of this stuff is needed to prepare 3 liters of that 1 in 30,000 solution here? Okay, so let's work it out. But one thing that I would do is I would switch everything to milliliters. This is just how I did it. Let's see if it works out. Okay, so this is 1 milliliter in 30,000 milliliter solution. That's the ratio I'm thinking about. And if I'm going to do this in milliliters, I need this to be in milliliters as well. So there are 3,000 milliliters in 1 liter. If you are bad at that conversion there, just do some dimensional analysis. You have 3 liters, multiply it by. Okay, if you want liters to cancel out, put that on bottom. We want milliliters to stay. So in 1 milliliter, there's 1,000 milliliters. In 1 liter, there's 1,000 milliliters. That cancels the liters, and 3 times 1,000 is 3,000 milliliters. I mean, it's pretty basic math on that one. Okay, what I'm going to do is I'm going to set up a ratio, just like they set up a ratio. So 1 in 30,000, yeah, milliliters. Everything's in milliliters, so you don't even really need to write them. Is now X amount. We want it in milligrams, yeah? But I'm doing everything in milliliters, so I'm going to do it in milliliters right now. 3,000 milliliters. Okay, because it was given to me in liters, so I need to make sure I do everything in the correct units here, the same units. That's how you do these ratios. So X times 3,000 gives you 3,000X. Oh, this should be 30,000, my bad. An extra 0 on there. And then 1 times 3,000 is going to be 3,000. Now you can divide by 30,000 to get your answer here, which is 0.1. That's going to be in milliliters. 0.1 milliliters. Now, I know that water, 1 milliliter, is the same as 1 gram. Okay, I don't know if it's the same with all other liquids, but I'm assuming it's the same here because it worked out how the same way that I would have done it with water. So I'm assuming the density of this stuff is somewhere similar to water. So it allows me to just make this assumption that 1 milliliter is the same as 1 gram. Okay, so what I need to do is switch this milliliter into milligrams. Okay, well, right now I know that 1 milliliter is equal to 1 gram, like I said, right? So I can say that this is equal to 0.1 grams since they're 1 to 1. Now I just need to switch this grams to milligrams. So let's do the same dimensional analysis idea I did there. 0.1 grams, multiply it, set up your fraction. I want grams to be on the bottom so they cancel. I'll put milligrams on top because that's what I want to convert it to. 1 gram is 1,000 milligrams, and 0.1 times 1,000 leaves you with 100 milligrams. And there you go. That's how you do that problem. Now I saw another one that's very similar with a ratio. So let's do that one. It's number 31. How many grams of potassium, this thing is required to prepare 2 quarts of 1 in 750 solution potassium. Yeah. Okay, so let me get my pen here. Now, when I've been trying to click on this pen, it keeps on pausing it, so hopefully it doesn't do that. Yeah, we're good. Okay, so here's how we're going to do it. Now, one thing that you're going to need to know, and this is just an assumption I'm making here, and this isn't extremely close, but it's close enough to ignore it. One quart is somewhere similar. It's approximately 1 liter. Okay, so I am making that that same thing here. This 2 quarts thing is approximately 2 liters. Now, since it's approximately, my answer isn't going to be perfect. It's not going to come out to exactly this, but it's going to come out similar. I want to switch everything to milliliters because that's what usually people do their conversions in. So I'm going to say this is 2,000 milliliters. And if you're confused on that conversion, just look at the last slide that we just did. Okay, let's set up our ratio just like we did before. X amount of milliliters for 2,000 milliliters is equal to 1 milliliter for every 750 milliliters. Let's do some cross multiplication. That's 750x is equal to 2,000. And then you can just divide by 750. So x is equal to 2,000 divided by 750, which gives me right around 2.6667 milliliters. Now, notice it is asking me how many grams of potassium we have. Remember I said 1 milliliter is similar to 1 gram. Now that's really making a guess just based off of water, and I'm assuming this has around the same density of water because it kind of works again. So I can say that this is about the same as 2.6667 grams, which if you look at these answers, this is the closest to that. Now the reason why it's above it is because 1 liter is a little bit more than 1 quart. So that would approximate it a little high. Now, unless you're going to memorize your quarts to liters conversion, this is just a safe approximation. If you Google it, I can Google it right now if I have my phone on me. Yeah, I do. Here, I'll write the exact approximation. 1 quart is equal to, let me check what it is. Give me 1 second. While I'm Googling it, here you go. Here's a dad joke. Where did Santa shop for people on the naughty list? Think about it there while I'm Googling. So here it is. Okay, he shops at Kohl's for them. Okay, 1 quart is approximately 0.95 liters. Yeah, so if you wanted to switch it perfectly, you could have switched the quarts to exactly how many liters it would have been first, and your answer would have been closer to that 2.56 using conversions and everything. But I did not do that. I used an approximation. Okay, let's go to the next problem here. How many liters of 0.9% normal saline solution can be made from 60 grams of sodium chloride? Okay, so this one's just a simple formula you gotta have memorized here. Whoa, trying to get my pen. Here we go. Okay, a simple formula you gotta have memorized here, and let's work it out. So you're just gonna do grams per milliliter times 100 is going to be equal to the percentage amount here, okay? So let's just work this out. It says how many liters of this 0.9 normal saline is needed. So we got 60 grams of this stuff for however many milliliters we're going to have times 100 equals the percentage, which is 0.9. Okay, so what you can do here is let's divide by 100, and I need a calculator to work this out here. Actually, what we can, there's multiple routes to go here. Let's do 6 times 100. That's going to give me 6,000 divided by x equals 0.9, and then you can switch these, right? Or you could write this over 1. There's multiple ways to do this, and you can cross multiply. Let's do that. Let's write this over 1 and cross multiply. So it's going to be 6,000 times 1 is 6,000 equals 0.9 times x. And then you can just divide by 0.9. Yeah, and 6,000 divided by 0.9 is going to be, give me 1 second here, divided by 0.9. That's going to be 6,666.66. There's a lot of sixes in these things that you guys are asking me to solve. I don't know. I don't know why you guys are giving me these problems here. Now this answer is in milliliters. Okay, that's how many milliliters we have. We want to switch this to liters. So let's just do that conversion that I taught you guys earlier. 6666.667 milliliters times, we want to switch to liters. So milliliters needs to go on bottom so they can cancel, right? Liters on top. 1 liter is 1,000 milliliters, so you're just dividing by 1,000. That would move this over 3 spots, leaving you with 6.66, and it would just go on forever. So you can just say 7 liters. And there's how you get that answer right there. Yeah? Cool. Okay, let's go to the next one. To make a 300 milliliter of 5% dextrose solution using 10% dextrose solution in water, how much of each do you need? Okay, this is a simple formula. Let's set it up for you guys here. All it is it's the percent times the amount of one of the solutions you have minus the percent times the total amount you have. Okay, so in this case it says we want to make 300 milliliters. That's the total. So 300 times minus x equals the percent times the total amount, which in this case is 300. So there's your formula. Let's multiply this out. Now the percent of our dextrose solution that we want it to be 300 milliliters or 5%. Yeah, so this is going to be, over here it's going to be 0.05 times 300 equals, okay, now 300 minus the amount of the other one. The percentage of this, now this, here I'll start with this one actually, is 10% dextrose solution. So this is going to be 10% of the dextrose solution times however much you are going to use. Okay, and it's going, I'm sorry, I meant plus on this one. Plus, and the percentage of whatever percent the other one is of dextrose. Now this is water, so it doesn't have a percentage of dextrose in it, so it's 0%. Okay, so we're just going to do 0%. And then, so this is just multiplying it out and figuring everything out. So 0.1x, 0 times anything is 0, so all that cancels out, equals 0.05 times 300, which let me figure out what that is real quick. 0.05 times 300 is going to be 15. And then you can just divide by 0.1 to get your answer here, which is going to be x equals 15 times 0.1 is 150 milliliters. So that means you need 150 milliliters of this 10% dextrose. And if you want to see how much you need of the other one, we had a total of 300, so it's just 300 minus however much you had, which is 150, which would leave you with 150 milliliters of the other one, which is water. So this is water, and this is the 10% dextrose. And so that would leave you with this answer. Now, since it was water, that's why it was 0% here. I would assume most of the time you're mixing a 10% with something else that has a percentage. So it would be like whatever percentage right here. Okay guys, just to reinforce this idea, you're doing the percent of whatever solution it was. So I put X. I should have put a D for dextrose. I feel like I should have done that. This is the percent of the other one. And this whole thing represents the amount of water that's being put in. So it's 300 minus the dextrose. Since I know the total amount is 300, that's why I did that. 300 minus dextrose amount equals the percentage of whatever you wanted for your total times your total amount. Okay, let's go to the next one. Okay, 29. Give me a second, I'm looking for it on here. Guys, it looks like you have your work here. It looks correct. If a 5 milliliter of diluent is added to a vial containing 2 grams of drug for injection, resulting in a final volume of 5.8 milliliters, what is the concentration in milligrams per milliliters of the drug in the reconstituted solution. Okay, let me just get my pen over here. Okay, so it's saying the concentration in milligrams per milliliter. Okay, that's telling you what your answer is gonna be in your units, milligrams per milliliter. That's what all these things are in. Okay, so we want to do the number of milligrams divided by the number of milliliters of the entire solution. Well, you have a vial containing 2 grams of the drug. So if you want that in milligrams, I mean that's 2,000 milligrams. You're going to divide by the number of milliliters of the entire thing. Okay, you didn't know how many milliliters were in it before, and we added 5 milliliters. So what I would have said is you do 5 plus whatever amount you added in, but it just tells you how much you have at the end. Okay, it makes it easy for you. You don't even need to add anything. So we're just going to do 5.8 because that's the final amount of milliliters there are. Now, notice that I said before 1 milliliter is equal to 1 gram. Okay, that is obviously not true for whatever this is. Okay, this is some sort of more dense drug than water. Okay, so you can't use this idea on this. You can only use that on things that have a similar density to water. Okay, so you're just going to divide these things, and it comes out to 345, and then just keep your units, milligrams per milliliters, and you got your answer. Okay, and that's how you do that one. Let's go to the next one. Number 18. Okay, an IV solution is ordered to run 3.5 GTTS per minute. Now, what I learned... Okay, guys, sorry, I paused it while I was trying to get my tool here. Okay. So what I did on this one is, and this is how I started pretty much every problem, is I looked at the units that it wanted me to have. So it says it has this many GTTS per minute. Now I had to Google this. I mean, if you don't know, that is drops. Okay, so it's 3.5 drops per minute. It's a Latin abbreviation for drops. It contains 875 milligrams in a total of 250 milliliters. Okay, so what I would say, and I don't know if this is proper pharmaceutical methods here, but I'd say 875 milligrams is equal to 250 milliliters. In this case, how many milligrams will the patient receive per hour if the set is calibrated to 12 drops per milliliter? Now, so that's telling you what it is that we need to solve for, which is milligrams per hour. So what I did was I just worked with everything I had. 3.5 drops per minute. And I wanted to switch this to 60, well, I know this is the answer, but I wanted to switch it to milligrams per hour instead of drops per minute. And they give us everything we need in order to do that. So I just started looking at the units here. So the first thing is I tried to switch. I started with. Oh, I didn't start with this one. I actually started with this other one. 12. I guess you could have probably started wherever you wanted. 12 drops per milliliter. I'm going to eventually use both of these. So I was going to switch this to milligrams first. So because I need milligrams in here. Obviously, milliliters is not part of the answer. So I wanted to switch my milliliters to milligrams, and they gave me that conversion, yeah? So 250 milliliters is 875 milligrams. And those cancel right there. And remember, I told you earlier 1 milliliter is equal to 1 gram, which is obviously not the conversion here. But I think you can probably safely assume this if they don't tell you something else. Okay, that's my assumption though. Here, since they told you 875 milligrams is equal to 250 milliliters, then that's what you use. Okay, so I'm going to cancel out my milliliters, and that's going to leave me with 12 divided by 875 is 3.43 milliliters. Now just look at what you have across. So you go across. I do not have milliliters on top. I have drops. per milligram. Okay, so I still want it in milligrams per hour. So I'm not where I need to be yet. So what I did next was I took this 3.5 drops per minute, and I actually wanted it in hours, right? So I switched it to hours. So I just multiplied. Let's do this. Minutes on top, so they cancel. I want it in hours. And 1 hour is 60 minutes, right? So I just did that times that, and that gave me 210 drops per hour. Okay, now I have these two things that I can work with, combine them to get milligrams per hour. So what I would do here is you can start with whichever one you want. Um, uh, I'll start with the 210. 210 drops per hour, and I multiplied it. I wanted to get rid of the drops because drops is not part of the answer. Okay, so I'm gonna put GTTS on the bottom, and I need to have something that it's equal to. In this case, I know 3.43 drops per milligram per milligram. Okay, so I know that 3.43 drops is equal to 1 milligram. That's what this conversion is telling me. So I can just do that divided by that. Now that's going to cancel out my drops, and it's going to leave me with 210 on top here. Now let me divide that out. Oh, it looks like I already did here. That divided by that comes out to 61.22. And if you look at the units on top, all it is milligrams divided by the units on bottom, which is just hours. And that's exactly the units I was looking for, milligrams per hour. So it's just a whole bunch of unit conversions on this one to get to your answer of 61. Okay, let's go to the next one. Okay guys, here's the last one, number 35. Let me get my pen out. Okay, if an IV solution containing 20,000 units of heparin in 500 milliliters of 0.45% sodium chloride solution is infused to provide 1,000 units of heparin per hour, roughly how many drops per minute should be infused to deliver the desired dose if the IV set calibrates at 15 drops per milliliter? Okay, so what I noticed is what I was doing again, which I do this on almost every problem, is I look at the units it is that I want to get to, and I start looking at the problem. So I want drops per minute, and I have drops per milliliter. So let's start out with that. Drops per milliliter. What I want to do is multiply by something to cancel out the milliliters and switch it to time. Okay, so let's just look at some of the stuff I have here. I have 20,000 units of heparin in 500 milliliters of this stuff is to be infused to provide 1,000 units per hour. Okay, I know I want 1,000 units every hour, but they gave me 20,000 units. Yeah, so what I want to do is let's see how much percent of this I need to be using, because I want to know how many milliliters are going in there every hour. Since there's 500 milliliters and 20,000 units, I'm going to see how many milliliters is in 1,000 units. And I just came up with something in my head here. Let's do this. Let's do 1,000 units over 20,000. Let's see if this works here. Units equals, let's do a thing here. So in the 1,000 units, I want to see how many milliliters there are in the 500 milliliters. So I set up, so 20,000 units has 500 milliliters, 1,000 units has how many milliliters. So let's see here, this is going to be 500 and 1,000, right? Equals 20,000x. 1,000x. Okay, let's divide there. So we're going to get x is equal to 500,000 divided by 20,000. And just canceling out some stuff here. So we're going to have 50 divided by 2, which is going to be 25, right? 25 milliliters. Okay, so in 1,000 units, there's 25 milliliters. So let's do this. 25 milliliters That way I can cancel out the milliliters here. I need to know how much time. I need a unit of time is equal to this. And we're doing it per hour. So we know that there's 1 hour should equal 25 milliliters. So let's just multiply these things out here. So 15 times 25 is going to be, that's going to be 375. And look what I did here. I canceled out milliliters, and I'm left with on the top here, drops per hour. And I don't want drops per hour. I actually want drops per minute. So what I can do is I can switch this to minutes, which you either divide this by 60 or use dimensional analysis here. Hours on top, minutes on bottom. 1 hour is equal to 60 minutes. That would cancel out hours, right? Okay, that's 375 divided by 60. I'll do that real quick. It's going to be 6.25. And you look at what you have left on top, which is drops per minute. And there you go, 6.25 drops per minute. So what I would do on a lot of these is what I noticed is I looked at the units that were needed, and I looked at a lot of the stuff on here, and I try to figure out how I can use dimensional analysis to come up with the units they want me to have. Yeah, and that's pretty much how I did almost all these problems. And I hope that helps out. Ask me any questions if you have any. Good luck.